Hello everyone. My name is Pye Pyo Jo, and I am a master student at Structural Engineering Division, Civil Engineering Department at Chulalongkorn University, Thailand. Today, I would like to present a topic named Behavior of Prestressed Concrete under fire and elevated temperature conditions. This is a partial requirement of the final report of the course. So these are the contexts that I will be presenting in this video. The first one is the challenge fire versus concrete, and the second one is critical temperature thresholds, and the third one the spalling phenomenon. Another one factors influencing fire endurance, and then I will present a case study based on the research paper that I studied, and then another one is inside of the building of fire. And after that, assignment methodology, final element analysis, and simulation results. And after that, I will end the presentation by doing final recommendation for the research paper. So the first one, the challenge, fire versus concrete. So as we have already known, the concrete is highly durable. However, when it is exposed to extreme temperature conditions, fire in this case, uh, we need to study extensively in order to understand how these structural member, especially concrete, responds to extreme fire. So, concrete is generally recognized for its high capacity to resist fire. However, in order to safeguard the building and the resistance of the building, of course, we need to extensively understand the microstructural alternations of the buildings. Another one, thermal dilations. So elevated temperatures called restrained thermal dilations due to kinematic restraints. So this modifies material behavior, leading to internal pressure buildup and potential structural failure. Critical temperature thresholds. In this case, they will be divided into three categories. The first one in 100 degrees Celsius, the second one 300 degrees Celsius, and the third one 450 to 300 degrees Celsius. The first one, at 100 degrees Celsius, what happens? The initial heating happens. The pool water inside the structural members, concrete members, evaporates. Another one, at 300 degrees Celsius, the differential movement happens. Aggregates expand and cement shrinks. So this is the difference. At 450 to 700 degrees Celsius, chemical decomposition happens. Calcium hydroxide breakdown happens. So the spalling phenomenon, where is the spalling phenomenon? The spalling phenomenon is basically a cumulative effect of high internal pressures from vaporized water. As I have presented before, at 100 degrees Celsius onwards, the water inside the inside the bed, and the members evaporates. So the differential diameter expansion leads to a critical failure mode known as spalling. So this violent breaking of the concrete surface layers effectively peels away the structural protective sheet. So as the protective sheet is removed, the internal materials, which is these, exposed to the air and the failure happens. So further influencing fire endurance, applying load, strength characteristic, and concrete cover. Applying load, the actual weight of the structure mass supports during the fire event directly impacts survival time. So another one, strength characteristic. Steel loses strength or rapidly at its heat maps. So the strength temperature relationships of precise strength is critical. And the third one, concrete covers. The concrete cover acts as a time machine, a protective sheet. So the time for strength to reach critical temperature depends on its thickness. Case study, based on the research paper that I use, test time fatigue profile. Here on this slide, I have put the put the images of the building, the slab, and the building type is two-story building operating as a textile factory. Structural system is pre-tension briquettes hollow core slabs. Dimension is 1.29, 0.265 meter. Reinforcement used is 6-strength, half-inch diameter strands, and located near the portion of the slab. So, um, the inside of the building after fire. So, as we see here on this surface, we see that a lot of damage happens, and also the concrete members cracking also happens. Assessment methodology. So the first one is design reviews. The authorities or the engineers, the professionals review original drawings to establish baseline parameters and identify critical material characteristics. After following that, field investigations. Um, they go to on-site visual inspections to match fire severity and non-destructive testing. Entity. And lab analysis after field investigation, they took some samples and then they sent them samples to the testing center and then to lab analysis. And also, they do FEA simulation, which is finite element method simulation. Non-destructive testing entity. There are three entities used in this research paper. The first one, rebound hammer test, and the second one is ultrasonic pulse velocity test, and the third one is visual indicators. Rebound hammer test. So the main purpose of using the rebound hammer test is to measure the surface hardness of the concrete. Because fire softens the concrete surface, swelling, microcracking happens. So lower rebound numbers indicates reduced compressive stress. Ultrasonic pulse velocity. So the main purpose is to send sound waves throughout the concrete to detect if there is internet voice, crack, or density changes happens. So the visual indicators. There are two floors in this building. So the first floor is highly severe. So the concrete surface is a bit pinkish color, and then some places is give reddish colors. So these pinkness and reddish colors typically means that the concrete has been exposed to temperature between 300 and 700 degrees Celsius, which is really hot. And then as for the second floor, it is lower compared to the first floor. However, in this floor, the surface were in some places the surface were black, so it is likely due to smoke decompositions. So sometimes it's really hard to know the color indications because of these surface blackness. Lab analysis course. In this case, I have presented the images of a code assembly took out from the of a structural member. So the main purpose is to determine the accurate compressive strength of the concrete in various structural elements. So assembly strategy is course with specifically different locations where the concrete surface exhibited discoloration, ensuring that symbol represented the fire damaged material. So the finite element analysis. So this is the representation of the member used in the building. They they model the member in finite element analysis in SYS software, and then they analyze the building. So the simulation results. For the first floor situation, the first floor represented the most critical scenario due to direct surface heating. It means the fire is exposed from the top and the bottom as well. The thermal isotherms reveal a rapid temperature rise throughout the cross section, causing significant degradation in both the siliceous aggregate and the heat sensitive prestressing strengths. So, the final recommendations. So, in this research paper, there were a lot of testing non-distress, distress, assembly, simulation, and after that, the research paper, the author give out a final recommendations, which is demolitions, because the failure mechanism is that the structural integrity was compromised by extensive spalling. Losses of cover losses happens, and then internet strands are exposed to air, uh, which could lead to the total failure later. And so severe loss of pre-stress forces due to steep realization happens as well. So it's really dangerous. And so the final conclusion is that rehabilitation was deemed impractical, costly, and risky. Not only impractical, not only costly, it's also risky as well. So the structural damage exceeded safety limits for repair. So instead of doing retrofitting or repairing processes, the other recommended to just demolish the whole building and reconstruct the facility. So the recommendation is complete demolitions and reconstructions of the facility. So in this presentation, in this report, that I used the research paper named "A Case Study on Fire Damage Assessment of a Two-Story Building with Precast Pretension Holocaust Labs." So this is the author, and this is from the Civil Engineering Department, the University of Jordan. Yes, thank you so much for your attention. Have a nice day.